cool. Thank you for the attendance note. All right, cool. So yeah, let's talk about the ODPs first, and then let's talk a little more about PA4 stuff. Let's start with ODPs. So 417 was this remove one function that removes a single x from an input string. And the previous ODP, here was a solution for it, right? So keep track of an output location and march through the input string up to and including the null terminator. So I said less than or equal to string length instead of just less than. And if the input character is not an x, it gets copied to the output string and the output location gets incremented. So that was ODP 416. The modification to remove a single x is basically just add a flag. So we've got this done flag, and the meaning of done is, hey, we've already removed a single x. We're done with the removing part of the show. So done starts off at 0. And so this is, you know, has no effect. And so this is the same as what we had in 416. If the character is not an x, we'll go ahead and copy it from the input to the output. But the first time we encounter an x, this condition will be true and we'll set done to 1, which tells us we have already skipped the x that we're required to x. We're done skipping stuff. And so once that happens, the next time we go through our loop, this condition is guaranteed to be true. It doesn't matter now whether the character is different from an x or not, because done will always be 1, which is true. And so we're always going to copy from the input to the output. So that gets you this state-based behavior where in your initial state you skip an x. That moves you into a new state where you copy.
Condition check, it's going to check true or false.
This one?
Yeah, so like if you don't give it something to check against, it's gonna basically take it as a Boolean argument.
So if you just have a variable name, the rule is if this is 0, it's false. If it's non-zero, it's true.
Okay.
But I could have been more explicit and said if done is not equal to 0, or if inloc is not equal to x, or if done is equal to 1. Alright, and then 418 was this move function, where we're taking the first character of a string and moving it to the end of the string. And so here's one way to do this. This is probably a little more complicated way of doing it than what we described in the last class on Wednesday. But basically what this loop does is it goes through and it copies all of the strings up to and including the null terminator from the input to the output, but it shifts them down one spot. So I said output 0 equal to input 1, output 1 equal to input 2, and so on. And then when I'm done with this loop, I will be equal to the string length of in, so I set that position in the output string to be the null terminator. And that's always safe to do. And then if we had any characters in our string, I need to take the first character and copy it to the last spot in my output string. So I just used out I minus 1, which is basically string length minus 1, set that equal to save, which was my saved copy of the input string, first character. But you can do this in the other direction. You can go from 0 to string length and copy from in bracket I to out bracket I plus 1. And get there like that. So when you're writing code, what should we be doing? You know, the case of removing a single x, right? What are some good test cases? Try something without any x's in it. Try something with a single x. Try something with two x's. Try something with multiple x's. Try something with x's that are not next to each other. Try something with two x's that are next to each other and one x that's not next to another x. These are all slightly different cases. And there's ways that you might write your code that work really well for this case, but not that case. Right? And you want as many test cases as you can think of that represent different possible situations. A case where I have two x's next to each other but separated from other things is different from a case where I have two x's but they're separated by a non-x. And what about having x's at the end? And what about having x's in the beginning? Those are all different cases. What about having just a single x, or having just two x's, or having just a bunch of x's, or having an empty string? So there's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 16 test cases that you could reasonably try on ODP 417. And you don't want to write, 16 versions of your main program. And remember, a lot of times your function may work great when you call it once. It may break if you try to call it a second time. Or it may work great if you call it on a short string and then you call it on a longer string, but it may break when you go from calling it on a longer string to calling it on a shorter string. In particular, in issues dealing with null terminators. Right? If I forget to put a null terminator in my string and I've just called my function with this as the input, and the output turned into, something with a bunch of stuff, and now I call this with the input, if I don't put a null terminator in the right place, I'm going to see extra stuff in my output. And if I've done all of this, and then I call this, and I'm hoping my output's going to be an empty string, I'll be really, really certain if there's a problem with that, because I'll see, a non-empty string. And so now maybe I would write a function called test, which takes an input string, and I would do something like, remove one, that string, comma, I'd make some string 2, and then I'd print out, string, and I'd print out string 2, and I'd put delimiters around those to make sure that, I can see if there's extra spaces being added in and so on, and put a new line, right? And so here's a little test function, and so now my main program would be something like, test this thing, test that thing, test this other thing, and so on. And now I don't have to spend a lot of time, changing main programs and stuff like that. And, if I get down here and my function stops working because there's an X in the beginning, right? I could go ahead, I could, run in GDB, edit my code, so on and so forth. Once I fix it, I rerun my main program, I'm redoing all of my tests, right? And the output of each test is, here's the string going in, here's the string that came out. I can look at that really quickly, and if I see, HEX going in and I see some 20-character monstrosity coming out, I know there's a problem right there. So when you're doing ODPs, right, you've got some time to work on this, to think about this. Your ideal is the first version of the code that you write compiles and works perfectly on all your test cases. That's what you're shooting for, okay? You gotta set the mark high. So we're not always going to achieve that, right? It doesn't matter how long you've been programming, you're going to write code with bugs in it. That's inevitable. But your goal should be, when I write this function, I'm thinking about it, I'm working through the edge cases in my mind, I've got an algorithm, I'm pretty sure I've converted it into C correctly, I'm handling null terminators, etc. You're going to write this code, hopefully, the first time you compile it and run it, it works great. All right. If it doesn't, then you go ahead and you make changes and you try test cases, you use GDB and so on and so forth. You get to the point where it's working on all of your tests. Then you go ahead and assess it. And ideally, the first time you assess it, you got a perfect score. All right. Writing the code from your head to paper or, to an editor, that's what you do on a test. Okay? That's what you do in a coding interview when you're trying to get a job. That's what you do if you're transferring to PSU, they give you a coding test as part of the admissions process, right? So that's kind of an artificial sort of thing, but it's really good practice. But in on the job, you would write your code and then you would be testing it. And so you'll be doing these test cases and debugging and so on and so forth. At the point where you're running the assess command, that's the point where you're handing your code to your boss. Or handing it to, the next team that's going to be integrating it into a system. And the goal is, that at the point where you're handing this thing off, you've done such a thorough job of testing it that you're convinced it works 100% all possible cases. So the test cases on the ODPs are getting trickier, right? And they're not giving you a lot of feedback, and the reason for that is in part, to give you an opportunity to get more practiced with making test cases, thinking up test cases, and running a main program that will exercise your function. So keep thinking about that and working towards that. For ODP 418, for the move function, probably not so many test cases. Really, if your function works correctly with something like hello, if it manages to turn this into that, it probably works for all cases where you have 3 or more characters. And then just go ahead and do a few extra checks. Make sure it doesn't blow up on an empty string, a string with 1 character, a string with 2 characters. And try those, after you've done something like this. Do this, and then try your function with an empty string, see if the output string is empty. Then do this again to load some stuff into your output string, and then try it with a single character, and so on. And yeah, these are definitely tricky to look for sometimes, which someone in a chat just mentioned. GDB, if you run these in GDB, what you can do is on the way out of the function, you can print what the output string is, and it will show you, the entire contents of the array, and you have to look to see if there's a null terminator in there. You'll see stuff after the null terminator also, but you have to kind of look and make sure that 0 is in there. What's the best way to test for an array of characters when expecting a string? With no null terminator. I'm not sure what that's asking. If you have a variable that's declared to be an array of characters, there's really nothing you can do to tell whether that's what you're actually looking at, because it's just binary data. A string is an array of characters, but if there's no null terminator, there's really no way to know that either. I mean, if you've got something that's supposed to be a string, you kind of have to believe that everything up through the null terminator is part of the string. And if that's not the case, there's really nothing you can do to know that, because there's no inherent length to arrays in C. I mean, you could move forward until you segfault, and then you could say, oh, I guess this wasn't a string, but that's probably not what we're after. So when you're in GDB, you're actually looking at memory. And yeah, even if you have a null terminator in an array, if I make an array of 120 characters, and I put in, ABC, let's say I string copy that, well, my array is going to contain ABC and a null terminator, and that's all that the string copy is going to do. And what's over here in the other 116 characters? No idea. So yeah, you'll see gibberish in there, and that's always startling in GDB. And yeah, if someone hands you a string and they haven't put a null terminator, I don't think you can reasonably prevent a seg fault. Because you just have no way of knowing how much memory you should be allowed to look through until you give up and say, hey, this isn't the proper string. It's one of the things about C that, sort of worries people, that led to, the development of languages without such overt pointer access. So like Java, one of the things people got so excited about with Java was that there were no pointers. Well, there are pointers, but you don't actually interact with them the way you do in C. So these kinds of seg faults from going off the end of a string don't happen. But there's other ways to get in trouble. All right. So somebody in the, or some people in the previous section asked about service learning projects. So this is probably a good time to go over the SLP because it's coming up. We've still got a few weeks, but there's 2 deliverables coming up for the SLP. So November 23rd is the upload, and the upload is basically a 1-page poster. You've got a template that you can download, and you basically fill it in for your project. And it basically is a elevator pitch. It's the 1-pager somebody can look at and kind of understand, what you're doing and what you're working on, what progress you've made, and so on and so forth. And let me pull the one from this section so we don't get funny dates. So the upload is this 1-page PDF. So you can download this. It's a PowerPoint slide, and you basically fill this in based on where you are at the end of this quarter or near the end of this quarter. So project title, come up with something you want to call your project. Put the current date on there. If you have a name for your team, put that down. Full names of all the people working on the project. And then there's 4 sections in here. The first is the problem definition. So the idea is, right, in the presentation, if this was a physical presentation, these would be hanging, on your table or on the wall behind you or something like that, and people would come in, they'd walk around a room, and they'd read these posters. And this poster, which is, like a 17 by 11 piece of cardboard, gives people who look at it a basic overview of what your SLP is. So sections for this poster: problem definition. This is where you describe your project. So problem statement. What am I working on? I'm trying to build, glow-in-the-dark sundial, right? Scope of the project. So what parts of the project am I tackling? What parts of the project are outside of what I'm planning to tackle? So you want to define the boundaries of your project. One, so that you don't fall into scope creep where you keep expanding the project and you never finish, but 2, so that people understand, I'm not going to solve, this other problem. I'm just going to tackle this set of problems here. Schedule. So what is your basic timeline between now and June for this project? You can talk about resources. What things are required for this project? How much money, how much time, what additional people, what sort of expertise, things like that. So that's summarizing the problem itself. And then research analysis. So a lot of what you've been doing over the past 8 weeks has been digging into the background of your problem, figuring out what it takes to do what you're proposing in your SLP. So maybe you've discovered you need to learn about vision processing, and there's a package called OpenCV, but that only runs under these conditions, so I've got to learn how to do such and such, and then I'm going to take this short course on OpenCV, and I'm going to try to get these tutorials going, and I'm halfway through that process, right? And then once I have that, I'm going to need to get a camera, and I'm going to need to figure out how to tie the camera into C++, and then I'm going to do such and such, right? So what did you learn in researching your problem area, right? So this is sort of the results of fall quarter. right? So your analysis after that research, as far as how do you go forward, and then propose solutions. So what am I going to do in the name of tackling this SLP? So if your SLP was to come up with an appointment calendar that people can use on their phone and share appointments with other people, these things exist. But if that was your idea, what's your solution at this point? You've had several weeks to work on this and dig into it and do some research. So what's your proposed solution? And you could have block diagrams here. If you've got a software system, you could have some flow charts here. If there's multiple pieces to this, you could have pictures of how these pieces fit together and so on. So your selected solution out of the different approaches you've been considering, and then potential applications, just kind of this service aspect of the service learning project. Where do you envision this product potentially being used? It doesn't have to be realistic, right? Most of us are not going to take what we do for the SLP and actually build build a business around it. But if you imagine that this was going to be deployed, right, what would be the possible uses for it? And so this goes into a one-page poster. Chop off this sheet down here, right? So remove this instruction sheet and just have this one page. Save it as a PDF. Upload that to Canvas by the 23rd of November, and that's your SLP upload. And then sliced bread too, perfect. And then the following Tuesday, which is the 30th, there'll be some sort of presentation of everybody's SLPs. And this will take one of two forms, and I haven't decided which. I have to talk to Izad, see what he wants to do. But this will either be, in class, people will take turns sharing their screen and just give the class, a 5-minute pitch on what you've done for your SLP. So you describe, basically what's on your poster, talk about any weird issues you ran into, things you're excited about working on, and so on. Pretty low key. The second option, still pretty low key, but slightly higher key, is what we've done in the past, which is have a big shared Zoom room, and people from this class would come into this Zoom room at 11 o'clock instead of coming to the regular class, and we'll advertise this, and people from elsewhere in campus, outside Clark, and so on, will be able to move from room to room and listen to people's presentations. And within each room, there'd be usually 4 people, and they'll just take turns doing their presentation, about 5 minutes each, and they'll just round robin. And then people just come and go. And while you're presenting and you finish your presentation, people might ask you questions like, hey, how did you do such and such? Or have you thought about this? Or have you heard about that? And it's a very kind of low-key interactive thing, but it's a really good experience for helping you get further with your service learning project. Because you can work in kind of your own head on a project for, a number of months, and then you talk to somebody outside about it, and they might say something that takes you in a totally different direction, or clears a log jam that you had about how am I going to get such and such done, and they might say, hey, have you thought about doing this, or you might meet a student, who's like, oh, I've been trying to do the same thing, do you want to collaborate, and that would be cool. So when we're back to being in person, this will probably be an in-person presentation. And typically what we've done in the past years, pre-COVID, was we cleared out, the area, what we call the digital lounge, and the hallway outside of the classroom, and tables are set up there, and students basically stand around at the tables and have their posters, have anything they want to show and tell, and people from around the campus, people from around town come by and just sort of walk around, look at your poster, and if it's something that intrigues them, they'll just start talking to you and say, hey, tell me about your sliced bread version too, and so it's like I say, it's pretty low key, but it can be really useful in terms of answering questions about your project, maybe breaking some mental blocks, and it's also really good practice. And frankly, it's a lot of fun to talk about stuff you're doing, especially if it's something you've been working on, you've been down in the trenches, like, hammering out code for this project. It's really fun to kind of like come up into daylight and like, share this with other people. especially if they're enthusiastic about it. So that will be some form of presentation. So the proposal you already turned in was 25 points. The upload is worth 50 points, and then the presentation is 25. That's your 100 points for the SLP component. That is not the same thing as the final exam. The final exam is a separate component, and it's scheduled according to Clark's final exam schedule. So I think it's going to end up being on a Wednesday, but I'm not sure. Check Clark's website. All right. So any questions there about Service Learning Project?
Yeah, okay. Oh, go ahead.
I had a question about the final exam.
Yeah.
It's still going to be like similar to like the midterm we took, right?
Yeah, it'll be a PDF that you download from Canvas. You write up your answers and you upload your answer sheet.
Okay.
And it'll be at some scheduled time, but probably not. It'll be a 2-hour exam, and it's scheduled whenever Clark schedules it for this section. All right, and someone else had a question?
Yeah, I'm kind of trying to think of a way to ask, but I guess so. My project's going to be basically trying to interface with Alexa and,
Cool.
and writing an Alexa skill for that.
Okay.
Amazon has a lot of really cool resources for that, and but so there are like boards that are ready for Alexa skills, like logic boards,
Mm-hmm.
but you still have to write the skill. Would that be all right, or do I have to just get a logic board?
Yeah, I mean that's reasonable. Like I say, you don't want to totally reinvent the wheel.
Yeah.
And so yeah, there's lots of good APIs out there for things like Alexa and other hardware systems. You definitely want to use those. Just make sure when you're thinking about scope of the project that it's not something that you're gonna do in 1 weekend or 3 weeks or something. It's something that you should be able to sink your teeth into and really make good progress on, from now until June, and clear milestones.
There'll be a little bit of engineering as well as writing code or writing a program.
Yeah, cool. Yeah, that sounds like a good area. There's lots of fun stuff you can do in there. Do we have to show any pictures or working prototypes of our project during the presentation? You can if it makes sense, but particularly in fall, this is largely about sort of figuring out what you want to work on and what are the bounds of the problem, and is this an area that's reasonable to work in? Is it a reasonable amount of work, and so on. So a lot of times I would say students at the fall presentation basically have their poster to show, and they're mostly just going to talk about what they've learned and what their plans are going forward. At the end of winter quarter, which would be typically March, I believe, it's more common that people have some sort of prototype. If it's a software project, you might have some initial version that you could show on a laptop. And then at the end of spring quarter, which would be June, that's where if people have gotten to some kind of working model, people would typically show it there. It's very possible that as you're working through this, you keep hitting more setbacks and you keep trying different approaches, and it may be that June comes around and you don't have a working prototype, and that's okay. That's I mean, the folklore is Edison tried 1,000 light bulbs that didn't work before he got one that did. There's great power in trying and not succeeding. It means you're making progress. So certainly for fall term, no worries at all. But the goal would be to try to get something that you could show some sort of version 0.1 maybe by end of winter, and then maybe version 1.0 by end of spring. All right, let's talk about PA4 stuff. So one question that's come up is if you have functions that you want to declare in one file and use in a different file. Right? So if you're collaborating with people on your SLP, you might have one person writing functions for doing, you know, input from the user, and another is making functions for finding appointments in your calendar book, and another one is doing some functions related to date arithmetic to figure out, you know, what appointments are in the future, and so on and so forth. And so let's play around with this. And yes, yeah, for fall term, having research on what you've done so far is a perfectly fine output, perfectly fine deliverable. You don't need to have something usable at this point. So let's make a function. I don't know. Show date. And so I'm going to use a dialog command, and I'm going to use the info box option, and I'm just going to, the info I'm going to show is going to be whatever the result of the date command is. And so I'm putting it inside back quotes to say, hey, execute the date command, but replace this back quoted string with the result of the date command. So this is like double quote, and it'll say, you know, Friday, November 13th, etc., etc. And so if I want to run this, I can say show date, and it will call this function. So if I make that executable and I say main2, it shows me an info box with the date in it. So if you're developing this with other people, maybe somebody else is going to develop this function that shows the date, and you just want to call the show date function. So I could write this into a file called, you know, functions. And in my functions file, I'm just going to say, you know, here's my function called show date. And I could write other functions in here that do other things and so on. Okay, so the question is, how can I, in my main bash script, get a hold of that function? And the easiest way to do that is to use the source command. So if you say source in the name of a file, what that basically does is at this point right here where we say source functions, it pulls all of this code in. In other words, it will take these statements and execute them as if you had typed them right here. So it's kind of like an include statement in C. So if I do this, this should set up the show date function's definition, and then if I say show date, it should go ahead and call that function. So if I run main2, let me clear it. If I run main2, right, it still shows the date. And then if, you know, the person who's developing this function changes it, to, you know, say something like today is, and then show the date, well, all I got to do is run my main program again, and it's using that new function. So that's one way to approach splitting things up. Now the other option is, you know, you can execute a function simply by typing its name, right? So if I just say functions, it will execute that script. But when you execute a script inside a script, that script that you're executing is being run in a subshell. In other words, a new bash process is being created to execute these lines of code. And when this script exits, and I come back to this bash script, it doesn't know anything about that function because it was created in a totally separate bash instance. So now if I do main2, it'll say, hey, I don't know what show date is. Oh yeah, and functions isn't runnable anyway. But if I make that runnable and I run main2, it doesn't know what the show date command is. Because this is not running as part of this bash shell, it's running as a new bash shell. So if you use the source keyword, that says go ahead and execute the statements found in this file as part of this bash instance. And so variables, functions, things like that are accessible now. And make sure, you know, you use the function after you've defined it. Otherwise, you know, if you use it before you define it, the function's undefined. Alright, so let's see. My little timer bar is off, by the way, because I made some changes. We got about 13 minutes. Let's talk about sed. So sed is a whole programming subsystem in itself. We'll talk about it later on in the course. But here's a way that you can use sed that may help you with some things in this programming assignment. Sed space and then single quote s/some pattern / some other pattern /g single quote. This is a really useful command, right? I spent about 20 years using sed, and this was the only command I knew. And it's still really, really useful. So what does this do? This reads from standard in, and on each line, anywhere that it finds this old pattern, it'll replace it with a new pattern. And so, for example, I can do the following. Is source preferable to creating new shell instances? It makes no difference. It's really up to you. If you need to access the things that happened in this other script, then you definitely want to use source. If you don't, you're probably better off running as a subshell, a new shell instance, so that, you know, variables that you create in this other script don't affect your main script. You really want to source it only if there's a reason to say, hey, I want to include all of that. So if I say sed, substitute a space with a comma. If I have a set of numbers separated by spaces, now they're separated by commas. Right? So this is a cool little function. It will take each line of input and replace all the spaces with commas. So if I type in my name, it puts a comma in there. Now, if I have a file, like, you know, calendar data, and let's say I want to replace these spaces in the description with underscores, because sometimes that makes life a little easier, right? I could do the following. I could say, let's type the contents of that data file, right? But instead of displaying it to standard out, let's take standard out and pipe it to standard in of the sed command. And let's say substitute a space with an underscore. And now I've got a copy of my original cal data file, but all my spaces have been turned into underscores. And I could take this and I could pipe it into sed and say substitute a pipe with a space. And now I've got my calendar file in a totally different format. I have 3 fields separated by spaces, and I have no spaces anywhere else. All of these spaces have been turned into underscores. And I could take this, and if I'm looking for appointments made on the 8th, I could pipe it into grep 2021-1108. Gotta put the pipe symbol. And now I can see all the appointments that were made on, you know, made for November 8th. And now if I just want to see the appointment name, I could use awk and print the 3rd field. And awk by default uses spaces as field separators. So $3 should be these descriptions of my appointment. And if I'm displaying this to the user, I could change those underscores back into spaces and there's a description of the appointments that the person might have asked for. If the person did something in my program and said, show me all the appointments that are coming up on November 8th, right, this would be what I want to display to them. Well, how would I display this information? I could capture it into a string using back quotes. So I could say something like data equals back quote. And now if I look at this variable data, it's got these two strings in it. But I can use this inside, say, an info box. So I could say dialog info box and use $data. And now there's an info box with the two appointments the person was asking for. So one of the nice things about working in Bash is rapid prototyping. Right? C, you gotta like figure out what the function is, and you gotta type it in, and you gotta compile it, you gotta fix compile errors, right? It can be a kind of slow, cumbersome development process. Bash, you can do rapid prototyping, right? I started off with looking at my calendar file, and then I said, let's go ahead and get rid of those spaces, and so on and so forth, right? And I'm building up these commands just by playing around at the command line, right? And I tried this and it didn't work because I forgot my pipe, so I went ahead and I did it again, but I added the pipe in there. And now I've got, this big, long, thing here that, I could turn this into one statement if I wanted. I could take all of this and put it right here, but we don't have to get too extreme, right? So this is pulling out the information from my calendar file for all appointments on November 8th. And then this is displaying those in an info box. And so if I wanted to do, I don't know what other dates I have. I've got some stuff on the 7th. So if I wanted to do all of this for November 7th, right, I do the same command, but I do it on the 7th. And then I do the dialog option, and there's the appointments that I had for the 7th. So obviously when you're making a script for this, right, this is some kind of variable. Like the person, said they wanted to see all appointments for a given date, and you said, what date do you want to see them for? And you popped up a calendar dialog. And you captured the output from that with the output FD, all that sort of stuff. And then maybe used awk to change it into this format, save that in a variable, and now you can do this statement. And here, instead of grepping this, grep for quote, $, chosen date, and save the result there, and then go ahead and do a dialog to display it. So you can sort of build this up from the command line, right, from this bash prompt, and see what you want to do, and then start putting those statements into that part of your script to sort of packetize it. But part of the fun of Bash is this notion of rapid prototyping, this fact that you don't have to compile, you don't have to get everything right the first time. You can sort of wiggle your way towards your working code. And it's, super interactive with all of this stuff. And so set is one of these commands that will help you. The other one that we've talked about before and I just used here is awk. Right, and I can say print, $2, $3, it'll print the second and third fields. By default, fields are separated by spaces. If I want a different field, I can do, F comma for a comma. If I want a pipe separator, I've got to escape it with a backslash, because pipe has special meaning. If I wanted to use a quotation mark, I would have to escape that, and so on and so forth. And awk, here's our calendar data, so I could say awk field separator is a pipe, and I could print fields 2 and 3, which would be the date and the description. I can pipe cal data into that, and there's the date and the description. And you can do remember to $3 on $2. So remember to make a new ODP on the 7th, remember to go to the store on the 8th, etc. So if you wanted to like pop up, reminders for people, you could form a string like that. And this is all just different ways of using this very small set of commands. So sed for replacing things in a string, awk for breaking something into fields, grep and grep-v to search a file for things, and all the rest is just the bash that you already know. Being able to make a loop to do things, being able to do if statements. If you're making a radio box, you need to build up a big list of things to display on each line. You can do that in a loop. Someone posted in Discord some ideas around building up radio list or checklist strings for dialogue, and all of that, together with a dialogue command. And that should be plenty for anything you're envisioning for PA4. But you gotta be willing to go in there and start figuring out how to put these tools together. And rather than look for is there a way to take the result from an info box and use it to generate this other thing, right? Think about how you can break it down into steps. So yeah, the exec function in bash, somebody's asking in chat. It's similar to using backquotes or using $paren, but I'm gonna suggest stick to using backquotes when you want to execute a command and capture the output. I think it minimizes a lot of the special cases. Stick to using $paren when you want to evaluate an expression, and stay away from exec. But it's well, this will get us a different exec. I mean, play with it if you want, right? But if you're just trying to figure out how do I execute a command and capture the output, I would stick with backquotes. But I'm thinking backquotes are probably a wrapper around some version of exec. But I've never used it, so that's as far as I can go. All right, so any parting questions on PA4? All right, go ahead and please send an attendance ping on the way out. And if I don't see you in 2:15, have a great weekend. Stay dry. Otherwise, I'll see you in a half hour in class. Have a good one.
I do have one quick question. As far as the main file for PA4, do you care what it's called?
Nope. You're gonna demo it, so as long as you know what it's called, that should be fine.
Okay, perfect. Thanks.
Cool. And someone said exec should be equivalent to $paren, which I think more or less functions the same as backquotes, except I think there's some differences. Cool. All right.
I did have a little side note that you might be interested. So the other day we were talking about how to address empty line.
Yeah.
And I found out that it does work. I just put it in the wrong place.
Okay.
The evaluating it to an empty string.
Okay. And I think I sent you an email with some use cases.
Yes, I believe so.
And I think the punchline on that was if you break the switches for grep out into a separate variable, life suddenly gets a lot easier.
Actually, I don't think you did send that to me.
No?
That might have been someone else. But I'd love to see it if you have it available.
Okay. It might have been a different issue you were talking about. This was the question of how to put part of a command into a variable and then use $variable to modify the command that you're executing.
No, so what I was having a problem on Thursday with if someone, like if I put up an input box
Mm-hmm.
hit enter instead of putting anything in there.
Ah, right,
and
right.
It would crash my program.
Oh, okay.
Yeah. So I figured out where to put it. I had to evaluate it after evaluating the status for that.
Oh, okay.
local box.
Cool. Just look for a non-zero status.
Yeah.
Okay, awesome.
All right. Thanks. Steve.
All right, cool. See you later.